Now remember, there are other letters in the alphabet, so let's try an example where instead of x and y, we use some other letters. Here we have a and b. 2a plus b is equal to 3, 5a minus 2b is equal to 12. Let's see if we can solve this problem. Now, again, I'm going to be doing it two ways. I'm going to do it where we eliminate the a first, and then another way where we eliminate the b after. Alright, so if you want to eliminate the a, remember the coefficients must have the same absolute value. Right now they are different. For a, in the top one is 2 and in the second one is 5. And we can make them the same simply by just switching the coefficients. Alright, for the a, here it's 2, so we put here down and we swap. For the a, here it's 5. And remember, when you're multiplying, it's each term you're multiplying. Alright? So 5 times each term. So 5 times 2a, that's 10a. Look at the space for the new pair. So 5 times 2a, 10a. 5 times b, that's 5b. And over here, 5 times 3, 15. Second one, 2 times each term. 2 times 5a, that's 10a. And 2 times negative 2b, that's negative 4b. And 2 times 12, that's 24, right? So we're subtracting. Let me put the subtraction sign over here. So we're subtracting. So 10a take away 10a, that leaves us with nothing, 0. Careful now. It's 5b. It's 5b, take away this. So again, I keep emphasizing, it's the term above, subtract the term below. So it's 5b, the term above, take away the term below, which is negative 4b. And the double negative now gives us a positive, so it becomes 5b plus 4b. So we end up with 9b. And 15 take away 24. Just a moment, let me just. So we end up with 9b. Because we're going to use that space on the right. So let me just undo that. And 15 take away 24, that's minus 9. So we need now the value of b, so we need to get rid of this 9. So we divide both sides by 9. Divide both sides by 9. And there, let me just continue up here. And hence we get 1b, 9 into 9 is 1, right? So 1b, which is just b. And negative 9 divided by 9. Remember, when you're multiplying or dividing, once the signs are different, the result is negative. So negative divided by positive is negative. So b is minus 1. Right, the value of b is minus 1. Good. So we need now the value of a. So as usual, we substitute the value of b into any one of the equation. Alright, let me use equation 2. Alright, doesn't matter if you use equation 1, same result. Into equation 2, right? Now here's equation 2. 5a minus 2b is equal to 12. So 5a, what's the value of b? The value of b is minus 1, so we replace the b with negative 1. Equal to 12. So 5a, and then what's negative times negative? Positive, right? So positive 2 is equal to 12. Alright, so we group the constants over the right. So 5a is 12 minus 2. So 5a is 10. So 5 times the number is 10. What is that number? So we can divide both sides to get both sides by 5 to get rid of the 5. Alright. 5 into itself, that's 1. So 1a. So 1a, which is just a, is equal to 10 divided by 5, which is 2. So the solution is 2 and b is negative 1. And we can always try them. Alright, let's try them quickly. If A is 2, then 2 times A is 4, agree? And if B is minus 1, then replace B with minus 1. That's positive 3. Here, if A is 2, 5 times 2, that's 10. And B is 1, so negative 2, B is negative 1. So negative 2 times negative 1 will give a positive 2. So 10 plus 2 is 12, so we're confident our solutions are okay. Now let's do the problem another way. Let's try do it where we try to make the B values the same. So now we have the coefficient for B in the top equation. The first one is 1, and in equation 2 it's minus 2. Alright, so I want to make this be 2. It doesn't matter if minus or positive 2. So we can multiply the top one by 2, and the other one we don't want to trouble it, because remember 2 and negative 2 have the same absolute value, because 2 and negative 2 are equidistant from the number line. In other words, equidistant from 0, In other words, the distance from 0 to 2 is the same as the distance from 0 to negative 2 on the number line. Alright, so 2 times equation 1, 2 times each term, we end up with 4a plus 2b is equal to 6. And then here, 1 times 5a, that's 5a. 1 times nothing changes, right? Now here, alright, add if signs are different, and the signs are different. Good. So we add for 4a plus 5a, that's 9a. And when you add 2b and negative 2b, what do we have? 0. Alright, so it makes sense to add, because think about it. If you subtract, what you'll have is 2b, take away negative 2b. Find the value of a, so we divide both sides by 9. Which means that the value of a, so 9 into 9, 1, so 1a. 18 divided by 9, that's 2. So the value of a is 2. And then to get the value of b, we can substitute the a value into, let me use equation 1 this time. Put EQ1 to abbreviate equation 1. So equation 1 states that 2a plus b is equal to 3. But we know the value of a is 2, correct? So 2a is actually 2 times 2 plus b. And then 2 times 2, that's 4. So 4 plus b. And then we're grouping. Alright, so we'll group the constants over here. So 4 becomes minus 4. Or if you want to say we subtract 4 from both sides. And 3 take away 4. That's minus 1. Same solution.